Ladies and gentlemen, a very warm welcome to all of you. I'm delighted to welcome you in the name of Buckingham University, of RAND Europe, and of the Convoco Foundation. My name is Corinne Flick. I'm the founder and chair of the Convoco Foundation, which celebrates this year its 20th anniversary. Today's lecture is the starting point of a lecture series with the focus on AI and its implications on society. Why did we decide to launch this series? For the first time, we are confronted with a technology that passed the Turing test. Just as a little reminder, the Turing test is a simple method to determine whether a machine can demonstrate human intelligence. Therefore, this is an extremely distinctive moment for humanity. AI will be more and more integrated into crucial infrastructure. Sam Altman suggests that within the next 10 years, super intelligent AIs will become reality. Hence, we need to take immediate action for the development of AI governance structure. On the one hand, AI holds the promise for dramatically improving our lives. Think of healthcare, office organization, or agriculture. But on the other hand, Elon Musk warns that AIs could pose a threat to human existence. And even more so, if the development is not accompanied with the ability to control it. Autonomous weapon systems, unintended outcomes of decisions in complex environments like financial markets, or when the goals of super-intelligent AIs do not match the goals of humans. This poses a danger of unknown degree. There is nobody who can predict in which direction AI will develop, benign or malign, or what the impact of AI will be on the future of humanity. Now the big question is, what is to be done? How should we steer the development of AI? One traditional tool is through regulation. There are different approaches of regulation, and we will talk about them later this evening. The topic of today's lecture is global approaches to AI governance. A very warm welcome to Jeff Elstodt. Jeff Elstodt is the director of the Center for Technology and Security Policy at RAND, and he's professor of policy analysis at the Pardee RAND Graduate School. A very warm welcome to you, Jeff. We are honored and delighted that you're here tonight. Thank you.
The goal for our societies can be to push out the frontier of technology capabilities as quickly as possible, while steering that expansion according to our goals for prosperity, security, and values. And the way the government can achieve this is by thinking of technology capabilities not as a point at a moment in time, but as a trajectory that unfolds across time. This is my thesis for the evening, so I'm going to say it all again. The goal for our societies can be to push out the frontier of technology capabilities as quickly as possible, while steering that expansion towards prosperity, security, and our values. And the way that government can accomplish this is by thinking of technology not as a point at a moment in time, but as a trajectory that unfolds across time. Hi, good evening. My name is Jeff Allstott. I've worked for nearly 20 years on technology evolution, technology forecasting, particularly as it relates to technologies relating to intelligence, such as artificial intelligence, but also other things like computational neuroscience. I did my PhD in that just up the road at the University of Cambridge, which I think is that direction or something like that. I split my time between Cambridge and DC, where I worked at the National Institutes for Mental Health, chopping up rat brains and putting them on electrodes. I tried to escape DC, went to Singapore and to MIT working on tech evolution issues, but the bald eagle got its talons into me, and I went to work in the US intelligence community. Is there an issue with the mic? I'm seeing some yes. Yeah. Is there reverberation?
There's a little problem.
We good? I don't know. People in the back can hear okay. All right. So I went to work in the US intelligence community where I ran programs on national security use of AI as well as security holes in AI, some things in biotech and things on analytic methods. I spent time at the White House of the National Security Council working on technology and national security policy. I was one of the architects of the US's AI chip controls against China, as well as R&D investment priorities and some things involving stuff the intelligence community gets up to. I still work in government a day a week at the National Science Foundation, where I run a program relating to R&D investment effectiveness, but the other 8 days a week I'm at RAND, where I run the Center for Technology and Security Policy, TASP, where our mission is tech competition and tech risks, or beat China and don't die. Clearly, I have a national security orientation, but later today we're going to be hearing from panelists who have other focuses, be that labor or equality and equity. These are also all valid elements of technology policy. I have a hypothesis that there are certain concepts within technology policy that will apply regardless of what domain you're working on, but maybe by the end of this evening we will see. So I said that the objective can be to push out the frontier of technology capabilities. I'd like us all to imagine that we are on a landscape together, looking out on fields and hills and rivers and mountains, and we are standing in the sunlight and there is fog obscuring most of the landscape. This is the landscape of all technology capabilities. And we, in the sun, are standing with the technologies that we and our ancestors have figured out how to make. And there's all sorts of wondrous things that humanity has figured out, and all sorts of things left to be done with the technology that we still have today. We can, we should, we must use those technologies in order to make people better off. However, as we look into the fog, we can see that most technology is still yet to be made. There's so many things out there. And in fact, there are glorious things out there. There are cures for cancer. There is boundless clean energy. There's AIs that will answer our emails so that we can spend time with family and friends, as I am looking forward to, as it is American Thanksgiving in a few days. But there are other things out in the fog. There are some bumps in the road. When I was 18, I went off to uni at a place that had a particularly good school of music, and I went to the symphony with this cute girl who was studying music composition. And both of us were excited because we were going out as independent adults for the first time to participate in this cultural experience. And for her, her colleagues were those who were on stage or in the audience. And so we listened to the beautiful music as it grew and swelled, and during a pregnant pause, her cell phone went off. And we both spun and looked at each other, and she was mortified and froze, and the cell phone rang, and it rang again. And then she got her wits about her, and she rummaged around in her bag and pulled out the cell phone and turned it off. Both of us scarred for life because of cell phones. Real tech, real problem, really small loss for humanity. We figured out how to deal with it, right? We've learned that event organizers say at the beginning of the event, please turn off your cell phones, and indeed most people have their cell phones on silent anyway. This was a problem coming from technology that we could take as a bump in the road and shrug it off as it got here. But there are other things out there in the fog. Smallpox is a virus that has a case fatality rate of about 1 in 3. It's R0, it's a bit over 3.5. It has killed hundreds of millions, if not billions, of people over the course of human history. Vaccines were invented to deal with smallpox. And I don't mean a vaccine was invented to deal with smallpox, though that is true. The concept of vaccines came about to address smallpox. And with this fantastic new technology in hand, humanity was able to begin war with the enemy, beating back smallpox further and further, until in the 1900s, with literally all the world's countries operating together, we were able to back smallpox into a corner and snuff it out. There are still samples of smallpox in refrigerators in the US and Russia, but smallpox is eradicated from the wild. No human needs to die from smallpox ever again. Real technology, real problem, real big win. The sequence for smallpox is online. It was sequenced and published during a time when there was no technology to boot up a virus from scratch. You can't just take the RNA and swivel it around and have a virus. You need to have all this sort of cellular architecture around it that can do that work. Today, those who study flu viruses in different labs who are collaborating no longer mail each other samples of flu. They email each other sequences for flu. And they do this because they have the technology to take that sequence and boot up the flu virus. Flu is unrelated to smallpox. You cannot apply that technology to boot up smallpox. However, in 2018, researchers showed that they could boot up horsepox from scratch, which, as it sounds, is indeed far more closely related to smallpox. Somewhere out there in the fog is the technology to resurrect smallpox. And when somebody does that, if they were to release it from, say, half a dozen, a dozen of the world's major airports, you could easily kill 1 billion people. And that's just from the virus alone, let alone all the knock-on effects that would bring down other people as the economy faltered. So what does all this have to do with AI? AI is an invention that helps us invent. AlphaFold, AI technology made right here in London by UK's own Nobel Prize-winning work, is an AI that helps you predict the structure of a protein given its sequence, which is immensely useful for medical technology and other forms of biotechnology. Today's large language models, ChatGPT, Claude, Llama, Gemini, these are all helping scientists. Today, we have a study out of MIT that showed that those using large language models for material science research were able to go faster and better and have larger impacts. Indeed, we can see large language models being used for all sorts of things. Someone from Deutsche Bank earlier today told me that they were using it regularly. So if cancer is cured or smallpox is resurrected, AI will likely be involved. At this point, civilization, thanks to AI and other technologies, is like a hypersonic fighter jet rocketing through the fog. And thank goodness that we are, because every minute that goes by that we do not hit our goals, that we did not hit our targets, people die. Smallpox, I said, it was nearly 200 years from the vaccine to be created for the eradication to occur. And if we had had our shit together, maybe we would have gotten it done in 100. Estimate would have been that we would have saved 500 million people from early deaths. And yet, if we are rocketing through the fog without radar, we are going to run to the side of a mountain. We cannot have an attitude of taking technology as it comes, just reacting to whatever appears as the fog rolls back. We need to be proactive. We need to be thinking ahead. And government in particular, for at least 2 reasons. 1, government has a mandate to be helping all of society. 2, government's really slow. And so if we try to merely react to things as they appear, we are going to screw up again and again and again. When governments fail to plan ahead, multiple kinds of things can happen. I have personally seen, and probably some of you have personally seen, instances where a government program was conceived, designed, approved, and rollout began, and midway through there, a new technology came out, making the whole program obsolete. Wasted effort. Could have been averted by pre-planning. I've seen this happen at DARPA, at IARPA, at ARPA-E for the energy sector, in places where people are supposed to be sophisticated scientists, just forget to ask the question of what else is everybody else doing and what is going to be coming down the pike. Additionally, when government fails to plan ahead, we have missed opportunities. We delay the arrival of those fantastic new capabilities. We delay the eradication of smallpox. We delay the arrival of the cure for cancer. We delay making our energy infrastructure more green. And indeed, when government does not look ahead, we do not prepare or address possible calamities, like the resurrection of smallpox, like some of the threats that were talked about earlier from other parts of AI. So, you agree with me. We need to look ahead. How do we actually do that? Well, if you are asking that question, you've already solved step 0, which is to try. So congratulations, if you are recognizing that the future will be unlike the present, just like the present is different from the past, then you're already ahead of 90% of people. The first real step is to start talking to the techies. So raise your hand if you are a policymaker or you work in policymaking and you do policy analysis, such as you're trying to serve a policymaker. All right, raise your right hand in particular. All right, leave those hands up. Raise your left hand if you are a no-shit, hands-on keyboard coder or in a wet lab or some other regime in which you are making real technology. Okay, the left hand and the right hand need to talk to each other. If you are near somebody who has a different hand up than you, give them a high five. See, someone needs to be giving Jan a high five over there. All right, good. You need to talk with each other after this. Because they need to talk with each other. Because the techies are the people who are at the edge of the fog, looking into there, imagining what can be there. And in fact, they are the ones trying to invent it. This is what they are oriented to. Sometimes those inventions that they are considering will be right at the edge, soon to arrive. Sometimes they will be out there, and they're imagining what could be. As much as I am a Cantab and it pains me to say it, there's some Oxford researchers who are particularly good at this. There's an Oxford professor, Eric Drexler, who calls this exploratory engineering. And there's a lot of things that you can identify from first principles about what is possible and what is not possible. I'm firmly in the camp, for example, that AGI is completely possible because we have 8 billion general intelligences running around now. We know a lot about computation. There's nothing to say that AGI could not be put on a different substrate and then have consequences. You cannot, however, make a diamond the size of a star because it'll collapse into a black hole. So we can know things about what exists or doesn't exist in the fog. Now, I said listen to the techies, but don't listen to them about everything. So RAND, our first publication, was, and I want to get the title of this right, the preliminary design of an experimental world-circling spaceship. This was about satellites. This was in the late 1940s that this report came out. It described satellites, orbital mechanics, and knew a bunch about the physics, having talked to the techies. And then the thing that RAND did was consider the implications of this, the implications on national security, the implications on economics, and so on. And this is a different set of expertise. So if you put up your right hand, you may need to be fully considering the implications on your own while still talking to the left-hand person about what these technology capabilities could be. Additionally, unfortunately, do not ask the techies when will the thing arrive. This is a separate skill set. Knowing inventions and the process of invention are separate things, particularly if you're talking about a process of invention that stretches out years and involves thousands or millions of people. But there are things that we can do for plotting out a trajectory into the fog of when different capabilities will arrive. And this is our second step. And the first thing you can do is just draw lines. So there's another Oxford professor, Doan Farmer. I will admit that both the Oxford professors here are Americans, but the Oxford professor Doan Farmer, who has identified that if you were standing in 1980 looking at the, at that point, historical trend of solar power, and you just projected into the future how much wattage you would get per dollar out of solar energy, you predicted now you would have hit it damn near exactly, 44 years in the future. And this appears again and again in different areas of technology where there's a trend, and that trend can continue over the course of decades. Most famous of this is Moore's Law about the cost of computing power. It is comical how often we have policymaking that does not acknowledge line go up. Line does go up often, and we should be, at the minimum, looking at the historical trend for areas of technology that we think are important and plotting that into the future and making plans accordingly. The difficulty is that sometimes line does not go up. In fact, sometimes lines slow down, line go flat. And so what we would ideally want is a mechanistic model to say not just what is sort of the default expectation of what is going to be happening with this trajectory into the fog, but what are the real forces behind it that would cause the trajectory to swerve around, and that then tells us also what are the levers that policymakers can be pushing and pulling that will change that trajectory. We have at least two kinds of mechanistic models you could try to bring to bear. One are mechanistic models that are general across many areas of technology. The second are mechanistic models that are particular to certain parts of technology. Unfortunately, after decades of work, we have really only identified one mechanistic model about technology writ large that actually holds up to significant scrutiny that applies across many areas of tech. There may be more yet to come. We're working on it. This is called Wright's Law, and it's the learning by doing or experience curves concept, that the more that you get reps in at making a product or a widget, the more you learn how to make that widget. We see this in particular in World War II, where governments were acquiring large amounts of different products, be those ships or bedrolls, and they didn't care about the price. But still, the manufacturers of those units, their cost to produce them was going down as they made exponentially more and more of the product because they were learning by doing. So, Wright's Law, one example of a mechanistic model predicting how trajectories will change into the future in the fog. But then there are other technology-specific solutions. We have in CPUs and in GPUs the concept of if you make the transistor smaller, everything is better. And this was the driving force, and still is the driving force, behind a lot of computer power improvements. This is called a scaling law, where you change the scale of something within the tech, then you get some performance yield. We see this right now with Frontier AI, where one of the central questions is about the scaling up of compute going into an AI's training or its inference, and how that yields additional performance increases. But you don't have to be talking about AI or computers. You'd be talking about more prosaic things, just manufacturing. Anytime you need a vat for aluminum or something else, the volume of the vat is the thing doing work. That goes up with the cube of the radius of the vat, whereas the surface area, the thing that costs you money, goes up with the square. So if you scale up the vat, you actually get more unit of good thing per unit of cost. So in fact, scaling up yields better returns. So these appear all over. The difficult part is, unfortunately, that you have to think through every part of the tech and actually start to do the systems engineering of how this will work into the future. It's very doable. This is the same thing that brought us the Apollo program and many other great technological feats, but it is, in fact, work. So now that you've accomplished these three things of talking to the techies, drawing some lines, and having mechanistic models that tell you what are the things that could be in the fog, where the trajectory is going, and what can be done to modify them, you have what you need to make plans. You can do things like R&D investment this direction versus that direction to hit something that we want to hit and avoid a calamity over there. You can be investing, yes, in R&D or certain elements of industrial policy and related spending. So that could be public goods for certain data sets or things like a telescope if that's needed. But there can also be sort of more basic infrastructure that is needed for the private sector to advance or implement the technologies that it already has. One of the big conversations right now is energy production needed for Frontier AI, both in training and in its deployment. This is, as I understand it, the origin of the sort of oft-derided talking point from Sam Altman of OpenAI about needing $7 trillion for AI. Most of that money isn't for the actual AI training or development, it's for building out the energy infrastructure, including transmission, so that there'd be enough energy to run all the chips in order to create all the AIs for all the people. Particularly large-scale bets that government could be making. In addition to pursuing these good things, there can also be these bad things in the fog, as we talked about. Here, there are opportunities, yes, to create guardrails, but also defensive tech. You can say, all right, you're just not allowed to make an AI that can tell anyone how to resurrect smallpox, at least not until we have a better solution for smallpox, be that vaccinating everybody or making a better biodefense program. Large language models can be used for cyber offense, which can actually be useful because we can run that large language model against all the software being used in our critical infrastructure to find all the vulnerabilities and then patch them. But that only works if you're using the LLM with the good guys first, and then you do your responsible vulnerability disclosure, let them patch stuff, and only then release it into the wild where the attackers are. So these are examples of plans that can be put forth, but you need to make them before the bad thing actually hits. Be that the LLM that can find 0 days in a bunch of critical infrastructure or smallpox getting released. You can't wait for the fog to roll back and find the monster and say, oh, now we will put in the plan, because then it does not work. So the vibe, the sort of mentality I want to convey to you here is that we need to be moving from this perspective of looking only at the tech that exists in the sunlight, but instead be standing at the fog, looking out on multiple trajectories and considering how we can pull and push different levers in order to change those trajectories. They can be moves that may not pay off now at all, but will pay off in 5 years or in 10 years on the basis of bets that are informed, deeply technically informed. There can be error bars on these trajectories. There will be bands of uncertainty. And so then that means that we will sometimes be surprised regardless. The fog will roll back and there will be some opportunity or threat that we had not anticipated at all or not yet. And indeed, we still need to be nimble in order to react to those things. But we cannot simply regress to the idea of we will react to things as they come. Instead, we need to be having this mentality of intentional policymaking that is strategic in its thinking over the course of years in order to be paying off over the course of a technology trajectory. If we can do this, we can make the future not just different from the present, but better from the present, where we can anticipate and more quickly approach those big technologies, those real technologies that will have real wins. And we can better anticipate and wisely approach and deal with those real technologies, those big technologies that could have real losses. So, the goal for our societies can be to push out the frontier of technology capabilities as quickly as possible, while steering the expansion of that frontier in pursuit of our prosperity, security, and values. And governments will be able to do this much better if they think of technology not as a point at a moment in time, but as a trajectory that takes place over time. In short, look ahead and steer. Thank you.